Hi class, this is Miss Slater. I hope that you all had a great spring break. Today we will be doing a classwork via this video. I'm not feeling too well today, so you'll hopefully see me on Tuesday. But in the meantime, I will be giving you this video as your classwork. We'll work through it, so essentially, you're going to watch the video and you're going to copy down what you see. Please watch along too, as I'll be talking about and explaining each thing as we jump into chapter 9, which is talking about angle relationships and angles. We're going to start talking about triangles more. This thing called the Pythagorean theorem is going to come up soon. Yeah, and this chapter is going to roll through just about right before testing, not spring testing, the state testing for math. So we will have our test, if I'm remembering correctly, planned for the first week that we start the state testing. And just to give you all a heads up, we will not have any math-related content. We will not be teaching anything new when you're testing for math. So we are going to be giving you a break then. So we want to get this chapter done before that testing starts. So, yeah. All right. So hopefully you have this pulled up on your iPad. This should be in the Canvas module where you found this video. The PDF should be there as well. So you're going to follow along. These types of angles part you probably already know from 6th and 7th grade, but an acute angle is an angle whose measure is less than 90 degrees. And we like to use visuals like this, like, oh, stop it, you. It's so cute. So, usually when I say cute, I talk in a little baby voice, and it's so cute. Whatever will help you remember it, that's always what helped me remember it. So yeah, an acute angle is less than 90 degrees. A right angle is an angle whose measure is 90 degrees. Exactly 90, can't be 90.1, can't be 89.9999. It has to be 90 degrees flat. And then if two angles that should be form. If two angles form a right angle, they are what we call complementary. So we'll talk about that a little bit more down below. But essentially, let's say I had a line cutting through the middle right here of this right angle. Whatever this angle and this angle adds up to would be 90 degrees. And these two angles we would call complementary. So they complement one another to make 90 degrees. So you don't need that line. Just if you want to keep that there for a visual, great. But that's a right angle. Complementary is one of those new terms that we're going to be talking about a bunch. So you might want to highlight that, know that. But complementary means 90 degrees. Okay. So we got less than 90, right angle. All right, let's talk about obtuse angles. So I always make my voice greater. But an obtuse angle, it's a large angle. It's an angle whose measure is greater than 90 degrees. So 90 degrees is kind of the one that the right angle is the standard, and then if you have anything less than that, acute, anything more than that, obtuse. And while we're here at this visual of an obtuse angle, I'm just going to show you really quick a couple ways that we would name this angle. So the first way would be going from this end to this end, going from right to left. So A, B, C, using all those vertexes. These are this is a vertex, and then these are the ends of it. So one way to label that would be A, B, C for that obtuse angle. But we can also go the other way, so we can go from left to right and go C, B, A. That's another way we can label it. One more label that we can give it is using the middle vertex, like I was saying, the middle vertice. So we can also call this angle B. And if you'll notice, they all have in common that B, at least for the first two, B is in the middle. And then for the third one, it's the middle vertices. So when we're talking about the names of angles, it doesn't matter if I say ABC or CBA. You just need to make sure that B is in the middle. So I couldn't say CAB because A is not in the middle, right? So CBA, ABC makes sense. So these are three ways that you could label this obtuse angle. And of course, we're going to talk more about that later, but just a little refresher, or if you did not remember that. Those are three ways to name that angle. Okay, last but not least, we've got a line. So the measure of a straight line, that's going to be 180 degrees. And then if two angles form, they spelled it right this time, two angles form a line, they are what we call supplementary. Supplementary. So as you can see in this visual down here, we've got this straight line. So that's going to measure 180 degrees. And then if I have this line in the middle, this angle is 30 degrees. This angle is 150, and we know that 30 plus 150 equals 180. So 30 degrees and 150 degrees are supplementary. So you might also want to highlight that in a different color. That's another term that's going to be super important in this chapter, knowing what it means. And I know that I used to get these confused all the time. So complementary, supplementary. So I want to give you a little tip to help you remember it. So for complementary, if we write out just even comp like that, if you were to draw a line right, I'm going to make it gray, right here between the C and the O, you can kind of see this 90 happening. And we know that complementary is 90 degrees, 90 degrees. So that's one easy way that you can think of complementary. Or if you and your friend are next to each other, you're complimenting each other, you compliment your friend. Yeah. And then supplementary, same thing. If we were to write out sup, if we add, this one you have to add two lines. So for this one, we connect the ends of the S's to make this kind of weird 8. We connect the top of the 0 and add a 1. That's 3 lines actually. And that you can see is 180 degrees for supplementary. Another way that I like to think about this is if you were walking this way and then your friend sees you and they're like, oh my gosh, hey. You would turn around. If you were facing this way, you would turn 180 degrees. So you would turn around 180 degrees. And then what would you say in reply? Sup. So those are two ways you can think of it. But just know that you're going to need to definitely know what these two things mean. So whatever way that you can remember, complementary means 90 degrees, supplementary means 180 degrees, you're definitely going to need to know those things. So start committing those to memory now so that when you get to the test, it's going to be super easy. Okay, so those are the types of angles. So now we can go ahead and move on to angle relationships. So as you can see here, this organizer's got the name of the angle relationship, a picture and a definition, and then examples. So for most of these examples, I will probably show you one part. So for example, for this one, I would do 1, and then you are going to be responsible for filling in 2, 3, and 4. And what's going to happen is tomorrow in class, as long as I'm there, we're going to go over those answers at the beginning. So you will need to make sure that those are filled in correctly. Okay. All right. So the first angle relationship we're going to talk about is vertical angles. This one's a really important one. You can see underneath it says congruent. I'm going to define that really quick. Congruent, if you remember back to our transformations chapter when we were talking about similarity and congruence, congruent means same shape. When we were talking about transformations at least, same shape, same size. So if we had 2 triangles, they were the same shape, the same size, they were basically the exact same, so at exactly the same. Okay, so when we talk about now vertical angles, this first fill in the blank is going to say congruent. So vertical angles are congruent. If you look at our picture, you can see it says, I'm going to explain that really quick, M angle 1. This is said measure of angle. That's how you say that, measure of angle 1. So if you ever see M angle 1, measure of angle 1, it's just another way to say what's the degree of that angle. So vertical angles are congruent. So measure of angle 1, this one, and measure of angle 3, this one, they're both equal to, they are exactly the same, 50 degrees. So this one and this one are the same degree. And you'll see that this line and this line, so we have these 2 lines crossing. So that's kind of what vertical angles are. It's when 2 lines, so in this case we have line CB, so this is line CB, crossing or intersecting another line AD, line AD. So whenever you have 2 lines that are crossing each other, you'll see that the angles that are opposite from each other, so either 1 and 3, 2 and 4, we can see that those 2 are going to be the same, congruent. And then you'll see over here, it's talking about that supplementary part of the supplementary relationship that I mentioned earlier. So if we just focus on, I'm going to actually just white this out for a second. Eep. So if I just white out this part really quick and pretend this is just one line, you can see this is a straight line. And in this straight line, there's a 50-degree angle and 130 degrees. This straight angle should add up to 180. 50 plus 130 is 180. And you can see that's what it's saying here. Measure of angle 1 plus measure of angle 2 is equal to 180. So those are supplementary. If we take that away and do it for the for this side, you can see the same relationship is happening between measure of angle 3, so angle 3, and angle 2. 130 degrees plus 50 degrees, that's going to equal 180. So whenever you see a straight line, you're going to know that it's 180 degrees, and that's going to help you find other values in certain relationships. So, for example, it says identify the 4 pairs of vertical angles. So that's angles that are across from each other. And really quick, I'm going to define that, or just let you know that this angle M, this line M and this line N, those are parallel to each other. And then this line, it looks like L, I think that's L, is crossing through the 2 of them. So to define these vertical angles really quick, I'm just going to pretend this bottom part is not here to help me figure out what are the vertical angles. So for this one, I'm actually going to give you probably 2. So the first pair of vertical angles, so I have this line crossing this line. So I said that vertical angles, the ones that are across from each other, are congruent or the exact same. So measure of angle 1, I'm going to say angle, oh wow, that's really big. Okay, there we go. There we go. Angle 1, that is going to be the same, congruent to angle 4. Those are vertical angles. Okay, so I'm going to put that back. So using that, there are 3 other pairs of vertical angles, and they're not supposed to overlap. So, using that, you can figure that out. Yep, okay. So that's vertical angles. That's that part. Okay, adjacent angles or a linear pair. You can see this supplementary word is coming back. And when you're looking at these notes, I think these notes are going to be a really great resource as you're going through homework and things like that. You can see it has some fill in the blanks that are going to tell you the really quick indicators of what each angle relationship is. So adjacent angles are supplementary. Adjacent angles. And if you don't know what the word adjacent means next to. So angles that are next to each other on a straight line. So they're next to each other on a straight line to each other. So adjacent means next to each other. But when we talk about adjacent angles, they have to be on a straight line. Okay. So adjacent angles are supplementary. They are also called a linear pair. So we can see that angle A plus angle B is equal to 180. Those are a linear pair. Okay, so now it's giving us an example of solving. So we know that angles that are in a straight line, they make 180 degrees. And this wants us to solve for X, Y, and Z. So if we take a look, I want to first look at this line. We only have one angle that is solved for. So I want to look at this line right here, like this top part. So I have a 65-degree angle, and I know if I'm on a straight line that the whole thing is going to add up to 180. So essentially, 65 degrees plus X should be equal to 180 degrees. And we know how to solve this. This is a really simple. I'm going to subtract 65 degrees from both sides because I want X all by itself. I want to know what X is equal to. So X is equal to 115 degrees. So the measure of angle X is 115 degrees. Now, using our vertical angles, we can tell what Y and Z are going to be without doing any more math. So these two lines are crossing, which means that if this is 115 degrees, Z also has to be 115 degrees. In the same way, if 65 is this angle, then I also know that Y has to be 65 degrees, okay? So you can see that using these properties, we're going to have to figure out other measures using the algebra that we know, solving equations. So it's going to bring back some old knowledge while also bringing in some new stuff. Okay, next page says parallel lines cut by a transversal. So I was talking about this with this example. So L and M are parallel in this picture. They are parallel lines. That's what this is saying. That double line says is parallel to. So L and M are parallel lines. So then N is a transversal. And a transversal is when another straight line crosses through two parallel lines. And when it does this, we get actually a pretty unique circumstance, because we have right here, we have two lines crossing, which will create some vertical angles. But we also have two lines crossing here, which will also create vertical angles. So we can figure out what angles are going to be equal to each other or supplementary, add up to 180. So it says using the diagram on the left, so this one, it wants you to find the acute, the obtuse, the pair of vertical angles, and the linear pairs. So the acute and the obtuse I'm going to leave for you because that's pretty simple. Does it look like it's less than 90 degrees? Again, a 90-degree angle looks like, oh wow, not like that. Like this. So or it can be turned the other way. So if it's anything less, if it's inside of this corner, then it's going to be acute. Anything more than that, it's going to be obtuse. So those are going to be some simple ones for you. The pair of vertical angles, so I'm going to go back up and look at what it says. Vertical angles are the ones that are across from each other. You can also use this example to help you. You kind of already got the answers there because it looks like it's basically the same picture. So the vertical angles there are going to be pretty simple. The linear pairs, on the other hand, those are going to be the ones that are on a straight line together. So one example of that would be on this straight line, this parallel line, cut by a transversal. So I want to think about the ones that are on the parallel lines that are being cut, essentially. So for example, one of those linear pairs is going to be angle 1 and angle 2. Angle 1 and angle 2. You also can just write this as 1 and 2. Let's do that to save some space. 1 and 2. There's going to be 3 more pairs here. And then you should get 4 pairs here. There should be 4 obtuse angles and 4 acute angles. Again, so you're going to fill in these blanks after this video, after you write down all of your definitions and such. Okay, so corresponding angles, these are angle relationships with parallel lines. So kind of when we have the parallel lines cut with a transversal, there's a couple different properties and ways that we can name the angles. So we are going to go ahead and do that. So corresponding angles are congruent. That's a congruent relationship. And that's also going to go here, congruent. And one thing I forgot to mention before is that the symbol to show congruency is an equal sign with a squiggly on top. Make that a little better. Squiggly line and an equal sign. That means congruent. So you'll see down here this like squiggly equal sign, squiggly equal sign. So it's not the same as is about equal to. It's saying it's congruent to. That means congruent. Yep. Okay. So corresponding angles are congruent. So corresponding angles are when we have a parallel line cut by a transversal. These are corresponding angles. These are corresponding angles. So you can see they're basically, if I were to get rid or like just pretend like the bottom half wasn't there for a second, it would be if I like duplicated this part. Nope. Hold on. Cut and then paste image. There we go. So if I were to just put it on there, which That's what transversal does, is it kind of cuts at an angle. This angle and this angle are going to be the same, which we can see that is the case. So those two angles are the same. That angle and that angle. This angle, that angle, that angle. Okay, so right down here, angle X is going to be congruent to angle X. Angle Y is going to be congruent to angle Y, Z with Z, and W with W. Which means they're going to have the same measure of angle. So if this is, let's say, 70 degrees, this is also going to be 70 degrees, so on and so forth. All right, so again, something we're going to be practicing a lot is finding different angle relationships and measures of angles using the properties that we know. So we can think about, I think, again, that property of a vertical angle is really helpful. But now that we know what congruent angles are, we can see that the ones that are, corresponding angles, I think I said congruent angles, corresponding angles are going to be congruent. So if this angle is 35 degrees, I know that also angle X has to be 35 degrees. If this angle is 35 degrees, the corresponding angle to that is going to be Y. So that's also going to be 35 degrees. And I'm going to let you figure out what A and B are. Okay. Alternate interior angles. Those are going to also be congruent. So alternate interior angles are inside the parallel lines. That means inside the parallel lines. And opposite of the transversal. The angles are, again, congruent. So as you can see in the picture, 4 and 6 are alternate interior angles, and angle 3 and 5 are also going to be alternate interior angles. So you can see they're inside the parallel lines. This is a parallel line. These two lines are parallel. And they are opposite of the transversal. So this is one side of the transversal. The opposite side would be over here. So this angle 3 and this angle 5 are congruent. So I know that angle 4 is congruent to angle 6. Angle 3 is congruent to angle 5. So using my picture at the left, I can see that 98 is going to be the same as angle X. To find what Y and Z are, you're going to need to remember that this is a straight line, and a straight line adds up to 180 degrees. So then what value of Y is going to satisfy that? And use your alternate interior angles to help you. Okay. Now we have alternate exterior angles. You might be seeing where this is going. Trying to find my page. Okay. Alternate exterior angles. You guessed it, they are also congruent. So alternate exterior angles are outside. So you might notice that outside, exterior, they are going to match the parallel lines, and opposite the transversal, opposite, alternate. Those angles, again, are going to be congruent. Yes. Here's my page. Oh, it just looks different. Okay. Congruent. So, same thing as the last one. Parallel lines. This is my transversal. But on this one, we see that the instead of on the inside, I can move it like this. There we go. So as angle 4 and angle 6 were the same, they were the opposite interior. We can see that same relationship happening on the exterior with angle 1 and angle 2. So angle 1 and angle 2 are going to be congruent, the same, and angle 3 and angle 4 are going to be congruent as well, the same. So this is the same angle as that. This is a different angle, but the same as that. Okay. All right, so this one's a little tricky. Julio wants to know if Franklin Way and Chavez Avenue are parallel. You're going to explain your answer. This one I want you to try on your own. So using the angle measurements that you have here and what you know about these different angles. So angle A, perhaps this angle up here, all those different things. How do you know if they're parallel or not? So I'm going to let you try that one on your own using what you know about alternate exterior angles. All right. I'm also just trying to wrap this up so that you have time to do so. Okay, same side interior angles. These are going to be supplementary. And remember, supplementary means 180 degrees. Okay, same side interior angles are inside the parallel lines. So again, that inside, interior, inside. However, they are on the same side of the transversal. Same side, same side. Those just match. Those angles are going to be supplementary. So as you can see, we have the same picture from our alternate interior angles, but we're looking at two different things now. We're looking now at the same side interior. So inside of the inside the parallel lines, but the same side of the transversal. So we're kind of looking at like this and this. So angle 4 and angle 5 are same side interior angles, but we know that those angles are supplementary, so that we know that angle 4 and angle 5 are actually supposed to add up to 180 degrees. And then angle 3 and angle 6, in the same way, should add up to 180 degrees. Okay. So in this example, L1 and L2, L1, L2, those are their parallel lines. L3 is cut by the transversal. So it wants you to find both the same side interior angle and the alternate interior angle. So 130 plus something should equal 180. And then what do you know about this angle and that angle? And you're going to fill in those blanks. All right, this is your last page, or last one. So same side exterior angles. Those are also going to be supplementary. And I know this is a lot of different terms coming at you all at once. I give yourself some grace when trying to learn them. Obviously, by the test, you're going to want to know the different, like how they work and things like that, so that you can go through the test pretty simply. But it is a lot of information right now, so I would not, please don't be so hard on yourself to remember it all by day one. With practice, it'll come. So when you're working on your homework tonight, please have these notes up alongside with it. So split screen your notes with your homework so that you can see, okay, when I'm working on, let's see if I can find it really quick. When I'm working on tonight's homework, it's going to ask me about this pair of parallel lines cut by a transversal. And it has three different situations. So it wants to know what measure of angle 2 and 3 would be if angle 1 is 63 degrees. So I would just pop open these notes and say, okay, what do I know based on what I wrote down with Miss Slater. Please don't try to remember it all right now. Like I said, it's going to come with time. And these are notes for you to refer to look at, all that kind of stuff. Okay. Same side, exterior angles are outside the parallel lines, and they're on the same side of the transversal. And the angles are going to be supplementary. I don't know if you just heard my stomach grumble, but if you did, that's hilarious. Okay, so same side exterior angles are right here. Angle 1 and angle 7. Another pair that is not labeled would be, let's say this is angle 2 and angle 8. So angle 1 and angle 7, we know that they're supplementary, so supplementary means 180 degrees. And what you can see with these different kind of angle relationships is angle 1 is an obtuse angle. That's more than 90 degrees. Angle 7 is an acute angle. It's less than 90 degrees. So typically when I have a number that is more than 90 and a number that is less than 90, or when I'm thinking about it, like this would make sense. If I were to cut and paste this, for example, over here, it would work. It's 180 degrees. So use that to help you remember these different relationships, because that's going to be helpful for you. Okay, and it wants to know if angle 1 is 180 degrees, find the measure of angle 7. So I'm going to set this one up for you. I know that angle 1 is equal to 100 degrees. I don't know what angle 7 is, so I'm going to leave that blank. And 180 degrees is what I'm trying to find. So you can just think of a simple mental, what would the measure of that angle be? Okay, so those are your notes. So to have them fully filled out, I would like you to complete this part, like all these parts that I did not fill in with you, using the notes that you have on the side. So anything on the right-hand side should be filled in. And then once you do that, you can turn this in on Canvas. And if you finish this all before the period ends, your next task is to start working on homework. So again, like I said, split screen this with your homework so that you can look at all the information while you're doing it. And if you have any questions on how any of this works or need some help, please have those questions ready for me when I come back Tuesday or Wednesday. We'll figure it out. But yeah, I hope your spring break was well. I am excited to see you all again. And yeah, have a great day.